Well, that's good enough. Yeah.
Okay, well, after that slight technical snafu, so I'll just introduce Kinsetsu very briefly, and I'm really going to try hard and not make this a sales pitch, because I really, what I'm trying to do is, I guess, just outline where we basically deliver IoT solutions and a little bit about what IoT can bring. But in terms of Kinsetsu, we are a Belfast headquartered software products company. We've been trading for about 6.5 years. We've developed our own software platform that is technology agnostic in the IoT space, and I'll come and talk about why that's important. We've recently secured funding of about 1.7 million, and we're now in scale-up mode. We currently have about 27 people in our Belfast office. We have an office in Galway, an office in Melbourne, and an office in Wales. And we are targeting on the vast majority of our business comes from the public sector, them deliver better solutions to their customers, because bluntly, their customers are us. They are patients, they are tourists, they are army personnel, they are citizens. Oh no, what's happening now? What's the problem that we're trying to solve with IoT? I guess at the top level, the whole kind of challenge that organizations are facing is lack of automated insight. And when I say lack of automated insight, I'm talking about automated insight into, for example, where people are, what the weather conditions are, what the carbon dioxide level of a particular room is, where a particular asset is, whether or not that asset is a medical device or a bed, where someone is on a Royal Navy ship. So it's all around basically trying to provide automated insight into business processes that are typically very manual and very time consuming. And what we do basically is we work with a vast array of IoT sensor manufacturers to integrate those into our platform to help organizations find things, measure things, and count things. I guess at one level, it's really no more complex than that. If I look at what a typical IoT solution looks like, there are 4 layers. On the left-hand side, you've got assets, and those can be anything. They can be people, so they can be patients in a hospital ward. They can be tourists on the Moran Mountains or in Derry City Museum or in Bangor Castle Museum. They can be pupils in a school. They can be any piece of equipment, whether or not that's a medical device, whether or not that's something, an asset that a power company or a manufacturing company uses. It can be a piece of equipment on a production line in a warehouse. It can be a vehicle in terms of a snowplow, an ambulance, a fire engine. It doesn't matter. There are sensors out in the market at the moment that basically will measure and count anything. And this, if you like, slice of the technology pie is the piece that is evolving most rapidly. So what wasn't possible even a year ago in terms of cost versus benefit is now, is now possible. So we're seeing devices now that are becoming much more multimodal. In other words, they can measure more than one thing. So they can measure temperature, shock, vibration, etc., all in the same device. And we're also seeing, obviously, the battery life of these devices is extending rapidly. Currently, it's around about 3 to 5 years. We're hearing that there are going to be devices being released that will now have battery lives of 7 to 10 years. So the sensor piece, which is the piece that is rapidly changing, as I say, it can identify people, so it can say how many people are in a certain room, in a certain lecture theatre, in a certain entertainment complex. It can count things, so how many items have I left within that particular stock item, and do I need to order more? It can locate and trace things, so it can locate and trace, for example, medical devices or patients in the community. It can determine the health of something. So has that asset been dropped? Has it been stored outside its normal operating conditions? Is it basically out of service and needs to be serviced? Obviously, it can determine temperature. So in terms of, is the device or is the asset being maintained within the right operating conditions in terms of temperature? And it can determine the level of things. So if you have essentially You know, if you're working in a manufacturing environment using lots and lots of parts, it can determine automatically when those number of parts reach a certain level and would then trigger an automatic stock reordering. The third level is the connectivity. So in terms of taking all this information from these devices and getting it back into the platform. And that connectivity can be anything from GPS SIM through Sigfox, LoRaWAN, NB IoT, Bluetooth. So the whole kind of proposition with Kinsetsu, and this is the only sales bit I'll mention, is that it doesn't matter to us what the sensor is or what the connectivity is, because we can work across all of those. And our bit is the bit on the right. So we ingest all these different sensor information, collate, aggregate, and then present that back to the user in either a digital map and or Power BI dashboards. All of this is all around providing this automated insight so that the user doesn't have to, for example, go up a mountain to determine what the weather is. He or she doesn't have to go to the forest park to determine how many visitors were in Tullymore Forest Park on the 12th or the 13th of August last year. All these events are monitored in near real time or real time, and that information is then pushed back onto the Kinsetsu platform. A little bit about where we work, to give you a bit of a flavor. So we work a lot on health. So working, helping organizations, including the Belfast Trust and the Southeastern Trust, for example, rapidly locate and retrieve medical devices. So the use case being that if a nurse or clinician needs a piece of equipment to do his or her job, they spend an inordinate amount going through rooms, going through cupboards. Our solution represents the current location of that device on a 2D digital map that the clinician has on his or her iPhone. And he or she can then ask a porter or go and retrieve that device immediately. We're working with the Royal Navy, helping them onboard and offboard ships personnel onto the Queen Elizabeth class carriers. And again, it sounds like a fairly prosaic kind of business requirement, but traditionally, this was a manual process whereby you would walk up the gangplank and someone would essentially log you in using what's called a pegboard. There are 6 ingress and egress points on these ships, and they're 5 stories high. So these are massive, massive metal boxes. So in the event of, for example, a medical intervention being required, you would have to, prior to using the solution, essentially go and try and find the person by going through each individual cabin and each individual bunk. Now what they have is a little RFID tag on their epaulette and their shoelaces, which locates them in near real time, and their location is represented on a 2D digital map of the warship. In terms of Northern Ireland, to make this a little bit more local, so we're working with some of the authorities in Northern Ireland, working with Ards and North Down, helping them automatically monitor the heat, light and temperature within Bangor Castle Museum. Again, sounds fairly prosaic, but traditionally this was done by someone coming in a few times a day with a probe and wandering through the exhibit rooms and then manually recording what the heat, light and humidity was. So we've put in sensors into the museum that are monitoring and recording this information 24/7, 365. And in the event then of such situations as air conditioning breaking down or something like that, that is automatically triggered that the environment within the museum is now basically not ideal for maintaining the exhibits. In Newry and Newry and Moran Council, we are working to essentially identify and locate and count people on the Moran Mountains. And again, you might think, well, why is that interesting? Well, it allows the council essentially to, if all the tourists are using a particular path, and that is damaging the kind of ecosystem on the mountains, they can then put up additional signage and redirect those tourists to other areas to basically maintain that ecosystem. So, I mean, at the end of the day, IoT is nothing more complex than basically, I'll stress again, providing automated insight into situations. Ideally, and where it becomes really powerful is that if those situations require manual intervention or manual tasks to be done. So if someone has to go and find something, if someone has to go and count something, if someone has to go and identify something, IoT is really, really well placed to automate that and provide much more real-time data insight. we're all about providing certainty. So we know where something is, we know where it's been, we know how many of them there are, we know where they've been and who has used them, and essentially the status of that particular item, whether or not it has been, as I say, dropped or mishandled. It always has to have a cost saving. We work 97% of our business in the public sector. We are very well aware of the continual financial pressures in the public sector. So IoT is all around building a robust business case that does show cost savings as well as the other softer benefits. Fundamentally, it's about releasing people's time. I mean, if we can replace manual processes like the Bangor Castle piece, like people, then frees up those people to do more valuable work and essentially, without diminishing the service delivery. And this is the only sales slide. So a little bit of some of the work that we're doing, working with Tourism and I, as I said, working with the Royal Navy, working with Bangor Castle Museum. And that really is awesome. Any questions?
Thank you, Ken. Has anyone any questions for Ken? You can shout out. I think you can unmute yourselves, or you can pick them in the chat. I'll keep an eye there. Or stick your hand up, whatever suits. Ken, you'd mentioned, and I don't know if you know the answer to this as well. I was trying to find out about, I know that the LP1 or LoRa network in Northern Ireland was really good, but who is that still running, or what's happened there? Because I was trying to find out about it, and it seems, I know Ulster University was involved, because it's a really good, if you're an agricultural, in agriculture or whatever, or remote, that was always a really good way that you could still use IoT, to track cows. I don't know, but you didn't have to have a mobile signal, and it was cheaper, and it was sort of
to answer your question, so yes, Sigfox coverage in Northern Ireland is pretty good. So the work that we have done, for example, with Newry and Moran, we have sensors installed up the Moran Mountains, and the Sigfox coverage is fine up there. Part of the, if you like, not the challenge, but something that needs to be always considered when you're proposing an IoT solution is, particularly if it's in a remote or rural area, is to go and do a site survey to determine what the connectivity is. Because even though we have worked across multiple sectors, both in buildings and out buildings, and we know the platform does what it says it's going to do, we are constantly amazed by, let's say, connectivity and availability, particularly in rural areas in Northern Ireland and Wales. So I'd say that in answer to that question, yes, but don't take it as read. Engage with your supplier and make sure the supplier goes and determines that the LP1 signal is sufficient. If not, then there are other options like, as I say, GPS, SIM, or whatever. They tend to be slightly more expensive, but I guess one of the benefits of our approach is that we provide a hybrid platform, so we can work with LP1, with Sigfox, with GPS, all on the same platform. So it doesn't matter to us, but it might matter in terms of the cost profile that the actual solution comes out at. Does that answer the question?
Yeah, no, absolutely. I'm just going through the chat here. Any other questions for Ken? And funny, I think we did a case study on the Ards and North Down Museum to try and explain IoT right at the beginning of the program. Niall Drew from the council gave us some background into that project. I didn't realize, he never mentioned who did it, so I hadn't put the dots together. Yeah, but it's a really interesting use case. There's the museum that has very limited funds, but the artifacts or exhibits, they can't be left, they have to be kept at the right temperature. And this was a solution that just really stopped somebody, as you say, somebody having to walk around and check everything manually. If something happened and nobody was there was alerts. It was a lovely use case, I thought, of IoT, just put really simply for something like
I agree. Yeah.
No, great. Any other questions for Ken? But it's great to see that this, and this technology, your platform, it's a Belfast, you're a Belfast company, and I think it's great to see that Northern Ireland, has such an impact on the different advanced technologies that we cover, but the IoT one as well. I know.
No, you were, yeah, we're delighted. Basically, I mean, it's a great industry to be in. It has got so many applications, and that's part of the challenge for a particular potential customer, is that because you can measure and count and monitor anything, where do you start? So if anybody on the call is looking at an IoT solution, the guidance I would give them is focus on the one key thing that if that is solved, will actually have a positive outcome on your business. Because for us, for example, we're working with Belfast Trust. We started off 6 years ago tracking 300,000 medical records throughout their estate. And that was a fairly easy business case to develop, because if they had to cancel an operation due to the unavailability of a medical record, that has a financial cost, and it also has a patient outcome impact. Since they put in that solution, they're now using the same platform to track wheelchairs, to track equipment in the community. So when you're discharged from hospital with your mattress and your commode and your wheelchair and your oxygen tank, they're also using it to track pathology samples. They're using it to track T34 syringe drivers, which are these end-of-life kind of morphine pumps. And I guess the message from that is that, as I said, focus on the one thing that you're going to solve that's going to create the most positive impact. Thereafter, there will be other use cases that you'll be able to deploy on the platform that possibly by themselves would not have supported enough of a business case, if you get me. So start on the big pain and then solve the little pain further on the line, further down the line.
Yeah, well, that's very wise. Mark, you have your hand raised. You can unmute yourself and shout out there.
Thanks. Morning, Kev. Ken, great presentation. Got a couple questions. Number one is around sort of interoperability. So you mentioned that your system ingests data from a whole host of different IoT sensors and potentially different IoT sensors within the same building and within the same context and business domain. I know a problem though is around standards that the data sort of defaults to and formats to. How does your system handle that?
That might be well above my pay grade. That sounds like a very technical question. Let me. Do you want to do me a favor? Do you want to ping me an email, and I'll have a chat with our CTO, and we'll come back to you on that.
Yeah,
I mean, fundamentally, answers is the same. Sorry.
Yeah, can do.
Yeah, no yeah. But just to get, if you could, that'd be brilliant. I'll get back to you. But I guess just to kind of, our approach to these devices is essentially zero trust. Okay, so we architect our platform on the assumption that the device is inherently compromisable. So we've architected that the information and the data that we are taking from the sensors, it's obviously encrypted at rest and in transit and all that good stuff. And it's also let's say, created in such a way that it is meaningless, let's say. So we're not storing or we're not taking anything like PII information. We're taking the smallest amount of information necessary, and then it's the platform itself that does the correlation between, if you like, that information, the event that it's monitoring, and the device. Does that help at all?
Sure. Yep. And just another question, throw a couple of buzzwords at you.
Not too technical. Not too technical.
It's you mentioned on one of the slides, I've seen there was around sort of machine learning aspect of it. Does your platform then support or like forecasting of what future data might look like based on what it's seen before?
Yeah, that's coming down the line. The way what we have found is that because fundamentally this is all about data, right? If you think about it, it's all about insight. And the insights that organizations get from using this platform, once they have access to all this data, is phenomenal. We're finding that they're basically being able to solve problems that they didn't know existed, because we're taking all this data from different sensors and aggregating it and presenting it back to them in a way that shows essentially that can relate, if you like, obviously things like number of people in a certain place to a certain weather environment or whatever. So the more data that the platform is ingesting for the customer, then things like the machine learning and the AI start to kick in. So yeah, in terms of being able to do, what if analysis, not yet.
I was just thinking as well, I know you're taking the data from the inputs, the whatever, I can't think of the word. But anyway, could you start to as well, and it's maybe on from Mark's point, so say for the Moran Mountains, could you also start to put in open data on, it's not IoT from IoT sensors, but like open data from maybe weather or whatever, and start to build up that.
Absolutely. The platform is an open API. Okay, so the platform can pull and push data to and from external sources. So we would typically be integrating with our customers. We will typically be integrating our platform with things like their asset management system or their service management platform. So as long as there's an ability for us to essentially pull in that open data through an API, then yes, basically we can aggregate that as part of the IoT sensor data and then present back the, if you like, that data insight in a correlated format.
Yeah, because I was thinking, like, for the example of the Moran Mountains, because to make I can get my head around it. If people are using a path, do they use this path that they're not meant to when it's rainy or snowy, and maybe when the weather's better, they stay away from that path that they're not really meant to be? Is that, I'm just trying to think of use cases of how you could be putting in other data to make sense of why are people doing this thing? It's because the path that we want them to go on is too slippy when it's wet, so we need to fix that path.
Yeah, absolutely. And there's other ways, because if you've been up in the Moran Mountains, it's a microclimate, so you can be down on the beach, basically having an ice cream, and think I'm going to go up the mountain. You go up the mountain and it's flipping blowing a gale. So the whole idea about the remote weather monitoring is to allow people basically bluntly to make decisions, and in the event of if you like, an intervention being required, the emergency services know the last known location of the people on the mountain and the numbers of people on the mountain. So it has, again, a lot of these use cases, you could class them as being fairly prosaic, but they do have fairly significant positive outcomes. So if you know where someone is, that means if you need to go and get them for a medical intervention, you save time. And that obviously has a very positive outcome in terms of the likelihood of a successful outcome for that individual.
Yeah, okay. Any other questions for Ken? Can I put your email in the chat for everybody? I should maybe ask your permission for that, but
not at all.
I know Mark has some questions for your technical team. Any other questions for Ken? Okay. Well, look, Ken, if you want, if it's okay, if you want to send me your slides, I'll send them out afterwards. But I'm sure people will be interested to see them, and there's a few people that weren't able to make it this morning and have asked as well.
Yeah. And anybody on the call that wants to reach out, I mean, in terms of discussing this in any more detail, or please do so. I mean, we're based in the Harbour Estate. We can be in the middle of town in like 10 minutes, and we're very keen to support Northern Irish industry, particularly obviously SMEs and scale-ups. So if there's anything we can do for you in terms of helping you with that, let us know.
Okay, so Ken, I'll let you go. If you want to make me host again, so if you go up to where you see my face and then hit on the top right hand corner, and then it'll say make host.
Okay, I don't see it. Where's your face? Oh,
you see my box anywhere?
No, let's more. Supposing something different on here. I don't see that. Hold on.
Maybe if you stop sharing your screen, it might.
Yeah.
More.
Okay, you've popped back up. I'm going to click on you then.
Yeah, please.
Is that you back as host?
I think so, because I do you
Oh
know
no, hold on. Make host. There could be pop-up box. Host the digital surge. Yes.
Oh yes, I called Digital Surge. Yes, brilliant. Okay, so Ken, thank you very much, and I know you have another meeting to crack on to, but I really appreciate you taking your time. That was really interesting.
No, it's not delighted to do it.
Brilliant. Okay, so I am now going to make morning, Sean. I'm going to make you host, Sean.
Morning.
That's okay.
Everyone,
Sounds good.
Thank you,
Thanks, Ken.
Ken.
thanks. Yeah.
So Sean Gilmour is the host now. So over to you. So big welcome to everyone. If you can give a big welcome to Sean.
Okay, I'll just get myself set up here now. 1 second here now. Okay. So can everyone see my screen, first of all? Or is that presenting correctly and all the rest of it? Excellent,
Yeah.
excellent. So this is going to be a very light-hearted, high-level introduction to AI and how it kind of fits into IoT. I think the IoT stuff was covered very nicely by Ken in that presentation. So I'm going to kind of lean more towards the AI and just give a general idea of what AI can do, maybe give you a few inspirations in terms of what you can do with AI and where it is at the moment. So first of all, if you can see this and you don't get this joke, then you definitely need the high level stuff, which I'm going to be covering. So watching a model train and watching a model train in the sense of AI is very, very different. And it essentially is one of the most difficult parts of training AI, which we'll touch on in this presentation as well. But what is AI essentially, if you're to break it down into its most basic constituencies or constituents? You essentially have a computer system that needs to learn something and then output the learnings of that information. And machine vision is one of the things we're going to touch on quite a bit in this presentation. And learning and training the AI is really important and can be quite difficult, especially in some of the applications that I'm going to show you. But in this particular application, you can see that the AI has identified a dog. Some AIs could even identify the breed of dog, the age of dog. It can identify it as a hat and the type of hat. But the level of sophistication that AI has at the moment is absolutely amazing. And hopefully I'll be able to communicate some of that stuff today. So this is an example of some of the AI being used by the automotive industry and other companies as well. So we have the ability to capture cars, but also there's a technology called optical flow, which essentially can take a car and calculate its trajectory, or people or any object, and calculate its trajectory and say, what speed is it going? What's its acceleration? It can look at signage. It can look at pose estimation. So you can see there's two people that are identified in red, and it says standing and watchful. So it can identify and say, there's a specific person on the side of the road, they're not paying attention. Let's maybe slow down the car in case they run in front of the traffic and get hit. So there's a lot of really, really advanced stuff being done. And this stuff is happening in real time on the vehicle using essentially supercomputers on a chip. And we'll go into that in more detail as well. The other thing actually I should mention is very happy to take questions during this presentation. So if you have a question, do feel free to unmute your microphone and just jump in. It'd be nice to have it interactive because it's easier to learn that way. So given another example of a construction site, computers can identify vehicles, vehicle types. Again, as you saw previously, the trajectory. It can identify people. So other things it can do in relation to people is it can identify what PPE they're wearing. So if you're doing, for example, health and safety audit, you can say this person is wearing their safety glasses, their helmet and their gloves, and they've got a certain colored high-vis vest, so they're allowed to be in a certain area. Or they're not allowed to be interacting with vehicles, so they shouldn't be in other areas. So you can do some really advanced health and safety stuff within building sites. You can look at things like subsidence or movement of structures and buildings for safety. And you can calculate and estimate intent from people and vehicles within that scene. And so effectively a really, really powerful tool for building sites or any kind of environments where you need to monitor complex health and safety issues. So other things, for example, on a building site that you might be able to use AI for is looking at aggregate quality. You could literally use a camera, take a look at the aggregate that's being used and say, this is a low quality, this is a high quality, it's the wrong quality, and have that validated in your building process. And an example of that could be, you have an instance here where you have mica content in bricks and cements and mortars, and it caused a huge amount of damage throughout Ireland and Northern Ireland. If potentially AI could have identified this at the manufacturing site to say this aggregate or this material we're putting into these bricks is not the right type, and it could have been spotted at an early stage. On the flip side of that, if the manufacturer had have used this type of technology, they could have said, well, actually, we've tested our bricks with AI. It's looked at the materials and that have gone into it, and here's the proof that we've tested it. So from a litigation point of view, companies can protect themselves by saying, we've actually looked at this, checked it, here's the evidence. So there's a lot of additional stuff, even just around the construction site, which is, they're prevalent everywhere, but there's just, it's really just touching or scratching the surface in terms of what AI can do. In addition to this, you can have a thing called sensor fusion, which essentially takes other sensors, which might be maybe temperature sensors or humidity or various other sensors, and you can add them to your AI algorithm to process in parallel with everything else to add more context to what your data is doing. This example here, this is actually quite bad now because I did this in a rush, and I didn't just stick little dots in it. Essentially what I did was I took a little video of my car and I asked an AI algorithm, a neural network, and I said, which parts of the car are vibrating the most? I did it initially, and it calculated over 500 points and filled the entire screen and showed where the points were and what was vibrating the worst and all the rest of it. And it just wasn't possible to display. So I just scaled it all the way down and just used dots to show how the AI viewed vibration or some of the worst vibration spots. These aren't generally the worst vibration spots. They're just a collection of vibration spots in this particular instance. But if you can imagine, if you had a 5K camera and you could, at a frame rate of 60 hertz, in theory, you could measure displacements in terms of vibration of up to 0.1 of a millimeter, which is at 60 times a second, which is absolutely phenomenal. And so the amount of data gathering and vibration analysis you could do with AI is absolutely massive. The other thing I'll throw in there is it's not just about AI can't just do vibration. As we saw previously, it can estimate the direction different things are moving. It can calculate potentially intent as well. So if something was about to break, it could identify a hose is vibrating too much all of a sudden, and something's about to fall off. So you could actually gather a huge amount of information in terms of vibration alone just with AI and machine vision. And we have here other types of images. So in this particular case, we've machine vision, but this type of machine vision would be processed on the cloud. You can do processing on the edge, and we're going to cover that now as well a little later on the process or in the presentation. But essentially, in this application, you have cheap video cameras. You don't want AI processing in every camera. Maybe you do, but in this particular application, you don't have to. You just basically take the camera feed back to your headquarters and you analyze it, you identify people, and you can track people through different camera systems, and you can calculate, again, pose estimation, their intent. Are they up to no good? Or are they just waiting? So an AI could potentially tell the difference between someone sitting there waiting for a train versus someone that's got some form of nefarious intent. Really, really impressive stuff. But again, AI, an application of AI on the cloud versus on the edge, where all the processing is on the cloud. And another example of AI processing would be on the edge. So in this particular application, we have like just a bit of a joke tractor here, but we have here on the left-hand side, you can see this. Imagine this as being a camera and another camera on the right-hand side. And essentially, you want the processing of that to be in real time, because if you're updating that camera information to the cloud and there's an obstacle coming close to the vehicle or the driver's approaching something and about to collide, then you've got a problem, because if you've got dropouts in your communications, if you've got issues with your processing speed, you will be too late to notify the driver and slam on the brakes. Whereas AI and the edge, you want to process everything in real time as fast as possible, and alert and warn the driver and affect the vehicle's movements based on what's happening in real time. So this is an example of edge processing, where things are processed in real time. I'll just go back to that as well, just in terms of the cost. I think I've covered this in another slide, but just in case, the cost implications of the edge processing is very different. So in the previous example, this guy here, you're talking cheap cameras, and you can put all your AI stuff on the cloud, and it's a lower cost of ownership, because you can buy cheap cameras and you can do all your processing on the cloud. Whereas in this application, you're buying more expensive cameras that are doing the processing on the edge, because they've got a supercomputer built into them, and then you're uploading more basic information to the cloud if necessary. An example of some stuff that I'm working on here in Northern Ireland, there's a company called Machine Eye, and they've developed an AI machine vision system to spot people in certain areas around heavy machinery. So essentially, the idea is that heavy machinery is a source of serious injury and death around the world regularly. And these machines, you can hardly blame the drivers in one sense, because there's a lot of blind spots around it, and it's very easy in a very busy environment to potentially hit someone. From a health and safety point of view, there's a lot of processes to keep people away from vehicles, but that doesn't always happen. Sometimes people go into the area, they want to talk to the driver, and they're breaking the rules, but there's no way of monitoring that or checking it. So essentially what this system can do is it can spot a person, it can flag it to the cloud, and it can say where these people are in relation to the vehicle, in relation to the site. And it can say whether there's potentially going to be a collision and warn the driver of that potential collision. And there's lots of implications for this as well, because again, this is off-road. The legislation for off-road vehicles isn't quite the same as for on-road vehicles. So this is a very new area that AI is getting into. And it's also much more difficult because in this particular application, AI is not referencing signposts or roads or paths. So it's slightly more difficult to gain contextual awareness of where you are. This is an example. This is a real picture taken from one of the cameras on board one of the machines. And I can't show you it with people, but you can see the amount of debris and stuff around the machine. There's a lot of activity. There's two machines working in the same area. So if a person was to walk onto that frame, it could be quite difficult, but it makes it even worse when you have, say, smoke and other things in the scene that can obfuscate the person, or any other objects in the image. The other thing as well is if you were to use radar or other systems for this same task, it wouldn't work well at all, because, for example, you can see on the right hand side, you can see there's another shovel here active, and the radar system would beep all day because you're in close proximity to another object. Whereas this system can identify, we don't care about the shovel, we only care there's a person there, notify the driver, make him stop immediately. But very challenging, and slightly more challenging than in the automotive environment, or the on-road environment, where you don't have this kind of clutter on the screen. I'll just give you a general idea of what the system's made up of. We have essentially a supercomputer, which is this guy here. We have some nice cameras, not quite this model, and then we've some 5G communication stuff. But to give you an idea of the processing power needed for this system, this unit here processes 21 tera operations a second. So that's 21 trillion operations every second. And if you were to compare that, and this is a bad comparison, NVIDIA wouldn't like this comparison, and it's not really a fair comparison, but if you compare it to teraflops, you're talking about 16 teraflops for that system versus a fraction of teraflop for a standard computer. So you're talking a factor of about 1,000 or more, or over 1,000 in terms of processing power that this guy has versus a standard computer. And that's necessary because in this particular application, you're analyzing a whole pile of stuff in real time. If you're late by half a second, that could mean the difference between the driver colliding with a person or the driver not colliding with a person. Other obvious examples for this type of application are where systems are working in close quarters with other systems, as I mentioned before, like, for example, a warehouse where you might have lots of forklifts moving around at speed. And again, you use radar or ultrasonic sensors, they're not going to work because the forklift is going to be surrounded by everything, you know, shelving, boxes, whatever. And ultimately, this is in this particular application, it's a health and safety device. So being able to spot and highlight people alone is a real benefit. Yeah, so pretty impressive stuff. Advertising, another good application of AI, and the amount of information you can gather from an image of someone is probably slightly disturbing in some ways. And this particular demonstration is very basic in what it can do, but it can essentially identify in this particular application that it's a person, it's a female. It guessed the type of job the person would do, a TV reporter. It suggested it was a young girl. It calculated its age, but it could also estimate whether you're happy, whether you're sad, whether you're pensive, and a whole range of emotions for that particular individual. It can also, as previously said, it can determine your intent, what you're doing, whether you're barbecuing food or you're going to rob someone. It can give you that general intent. So AI is, especially machine vision, is a really, really powerful tool, and for advertising in AI, really, really, groundbreaking. The other thing as well is this could be anonymized quite easily, and I'll go into some anonymization a little bit later. But anonymizing, you could essentially not capture the image, but capture the data, and say that a person has walked into your shop and they are a young female between the age of 21 to 24, and they're in a rush, and that information alone would be quite useful. And then you could track the person around the shop and determine what they bought and lump it in with a pile of other analytics without actually capturing the image of the person. So you can successfully do some level of anonymization with machine vision and AI in certain contexts. And just for the geeky people here, this is an example of a convolutional neural network which is used by us. And this particular one is called YOLO, and it uses basically it's a convolutional neural network, and it's a tool that we use to analyze how the network is performing in certain cases. So even though some of this stuff is quite complex, a lot of companies won't want this. And you can then try to augment that performance and improve the performance in various ways. So this application is called Zetane. There's lots of other applications, but it gives you just this very, very slight idea of the level of processing that's required. So in the left-hand side, these are all the various steps that happen. And this particular thing on the right is showing one step of about, I don't know how many images are on that, it's maybe 20 plus images. And in each step, each image, the neural net is scanning across with what's called a kernel to determine features. Oh, excuse me, I'll go back again, hang on. To determine features in the neural net or in the image. And it's scanning each image at least once, and then doing that with 20 images. And then for each box, it's doing that again multiple times. And I'm showing you here about a fraction of, probably not even, maybe 5% of the neural net is displayed in this window. Excuse me. So the neural nets are really, really complex and pretty big, but there's still stuff you can do with them. Excuse me. So other applications for AI, we can understand text with it. We can do lip reading, sign language. We can understand what people will respond to for advertising. We can do automation for manufacturing and driving. We can also do things like fall detection, predictive maintenance, engineering, art, and much more. And AI is getting to the point where it has been able to successfully replace people. We just have to look at GPT, where we really can see people doing coding through this AI. We can see them writing essays and various things through AI, and it performs really, really well. So we are going to see some issues in the future, I think, where the jobs market is going to maybe reshuffle a little bit to suit the growing capability of AI. So AI and privacy, I just thought I'd touch on this a little bit as well. So there's lots of different approaches you can do to protect the privacy of people. And the example I discussed there previously of the lady in the shop was one example where you could get rid of the image altogether. But other ways are, physically blurring the face. Incidentally, physically blurring the face doesn't necessarily prevent the AI from doing image recognition or pose estimation. So the way an AI works is it does edge detection, and it actually internally breaks down the image of a person's face in a way similar to this, and even abstracts it further. So an AI could potentially still identify people even though these images are blurred. And in fact, if you blur the entire image, you could potentially still identify people, and they do pose estimation and various things, depending on the level of blurring and pixelation. Another example we see up here is we see another AI company has completely painted out people in the frame automatically. And while you might say, yes, that definitely adds privacy, you can still calculate or estimate intent, and you could potentially still identify people based on habits and other data that you could augment to your data gathering. So it's actually quite difficult to get real anonymization through AI, but it is possible, but it's just something to be aware of. So IoT and AI, I thought I'd better touch on this as well a little bit because this is the digital surge presentation. So AI, essentially 5G is one of the biggest enablers for AI, especially when you're looking at machine vision and the amount of data that needs to be captured. And especially, again, if you're doing AI on the cloud, because you're going to want to capture images in real time and then process them on the cloud. So 5G is really, really key in being able to capture those images. And again, when we're looking at AI, we discussed this briefly before. If we're doing cloud processing on AI, we need to be, we'll have a lower cost of ownership for equipment. I'm just keeping an eye on the time there. We'll also have ongoing cloud processing costs because we're processing everything on the cloud, so the requirements there will be a little bit different. And the cost to own will be much lower, but there'll be a higher cost to maintain. So for example, you can buy 500 CCTV cameras, and they'll be cheap. They'll have no edge processing in them. And then you'll just be able to scale a cloud, excuse me, a cloud-based system. I should have grabbed a cup of water there or something. Excuse me. So in this particular case, if you're a startup, that might be a good way to go. If you didn't have to do edge or edge processing, you could process it in the cloud. You get a lower cost of ownership in terms of the cameras, and then you can scale your cloud-based system as your business grows. But as we discussed previously, processing in the cloud isn't always possible because you may need that fast response time. So when you're doing edge processed AI, you don't have to have the same bandwidth, although you may still want to upload images in real time, but it's not going to stop your safety systems from working because they're all working on the edge. The equipment is going to be more expensive because you got that extra processing element inside the camera. But there's going to be a lower cost of ongoing operation because your cloud processing requirements are going to be significantly lower. So again, with the edge processed AI, it's going to be more costly to own initially, but it'll be lower cost to maintain, depending again on how you've set up your cloud systems. And again, abstracting the data can reduce the communications requirements. So the logic of this is using that example of the lady in the shop. Again, if you're anonymizing that, you would just say a lady 21 to 24 has entered the shop and they're in a hurry and they've gone to these things and bought this. And that would be pretty good anonymization, but it's also abstracting the data, because instead of uploading a picture or a video of the person entering the shop, you're just importing the metadata saying, you know, who it is, what they're doing, et cetera, et cetera. You could break the law and say, you know, I've identified this person as X, Y, or Z, which would be, but, you know, and that's where the danger is, that some companies could potentially flout the law. You know, you could associate various hashes with people that come in and, you know, identify them the next time, say person X or person Y has come in versus a completely anonymous person. So yeah, but abstraction can help reduce communications requirements. I kind of went on a little bit there. So low-cost edge AI, there's a lot of low-cost edge AI technology emerging at the moment. And some like this Max board with a lot of IoT stuff built onto the board. Others like these guys here for really serious edge processing. And, you know, there's a huge amount of stuff available out there. The cost is dropping like mad for these. They can run different types of algorithms. So understanding the types of algorithms that run in these things is quite important. I've seen pretty big differences in performance between different algorithms, and especially how they're trained. So these things do give you the opportunity to use different algorithms in your AI system. So just on a very basic level, high level overview, AI essentially is like a processor within the IoT system. If you're developing a IoT AI system, there are different skills required. You've got the communications and the cloud management and things like that. But you've also got a different layer where you have to understand your neural networks, your algorithms and things like that. But these things are being abstracted more and more, so it's easier to learn these technologies and these skills. So I think as we move through the next few years, we'll see these becoming much more accessible and much more highly abstracted, that make it much easier for us to use. Also, test requirements are going to be a big challenge moving forwards. How do you test your neural net or your algorithm? I won't go into that too much detail. If anyone has questions on that, we can certainly dive into that a little bit more, but testing is going to be a big thing. Also, the implications of user interfaces. AI brings a whole new level of sophistication and functionality, and user interfaces can change as a result of that and potentially get a lot better. So rapidly changing landscape. If you're looking at AI, definitely do your homework, spend a bit of time playing around with different algorithms, look at different platforms, and you know, that's about it. And that's me. And
thank you, Sean. That was brilliant. Thank you very much. Has anyone? Oh, Raj.
I am 27 minutes in. I'm not too bad.
Yeah, brilliant. Your per voice though. Raj has a question. I'm going to read it out. What are the improvements in the AI towards water resources management on Earth? So,
yeah, so there's a lot of satellite AI systems that can look at the size of lakes and rivers and greenery. So even from greenery, I would expect that you can calculate how much water there is in the ground, or the ground table, or basin rivers. And yeah, there's a lot. But mostly satellite based. But again, you could use a lot of stuff, or there is a lot of stuff, I'm sure, in reservoirs. A lot of monitoring goes on in Northern Ireland in terms of capacity and usage.
yeah, and I know one of our other webinars, and I think it will be on our YouTube channel, Colm from Aneco spoke about the work they've been doing with NI Water on and I can't remember if it's an AI webinar, a big data webinar, or an IoT webinar, because and you're right, they're all so closely linked, those three areas. But it's maybe not on a global scale, but locally in Northern Ireland, how the public body that looks after the water supply is trying to address challenges with technology. I'll put a link when we go for a coffee break. I'll put a link to the YouTube channel and you can dig through. But you were mentioning as well about civil engineering. There's one of Mara Leiden from Queen's, the built environment there, she does a lot of work putting sensors and cameras on older bridges, that don't have all that sort of technology built into them, and just how they can see if stuff is really broken. Like there was people were phoning into the Nolan show, and if you're not from Northern Ireland, it's like this BBC show in the morning on the radio, and people phoning in being outraged about something, and people had noticed a big crack on one of the bridges on the M1, and people were like, oh my god, this is going to fall. But Mara and her team, without the road service or the DOE or whoever having to close the motorway and take the bridge, do all this work to the bridge, she was able to monitor the bridge with some sensors, IoT sensors, and get different things to drive across the bridge, and it was fine. It was just a very superficial crack, but her and the team using IoT and AI were able to work that out.
And again, another simpler way of doing that is potentially having just a single camera looking at it. If it's a high resolution camera and it's on a stable platform, even if it's not on a stable platform, it could potentially spot very, very small displacements in the bridge and look at nodal vibration across the bridge, which might be more difficult to do with certain types of sensors. But yeah, there's this huge amount of stuff that you could do with.
Mara's doing great. Yeah, loads of things up in Derry as well. The bridge, when everyone was walking across it, people were really worried that it was really bouncy. But they were able to put up cameras, and just
very good
monitor that. Any more questions? Mark is saying there's. Oh, go ahead, Michael.
Hi, Michael here from Graham Asset Management. We're obviously a facilities management company. I just had a question related to a couple of slides. One was around the construction site, and then the camera used in the car. So just trying to get an indication of what kind of price that hardware would be. And have you any kind of use cases where it has been utilized for the sort of predictive maintenance type models? We're doing stuff at the minute, but it's mainly AI around data models as opposed to the actual cameras.
Yeah, so there's different approaches again you would take in the construction sector. So for example, again, we have the edge processing where a vehicle, you need that real-time processing to alert people, and those ones tend to be more expensive in terms of the initial capital equipment expenditure, and you're talking, you could be talking £10,000 plus to install a ruggedized system into a machine. Then if you're looking at viewing the building site and looking at health and safety issues. So initially, just to point out as well, on the system I'm working on, they do you can do health and safety audits through the machines on the camera, or the cameras on the machines, because essentially it'll detect, is there anyone interacting with the machine that shouldn't be? It'll say where people are in the building site and if they're in areas they shouldn't, if they're wearing the right PPE. So you can do a lot of that stuff on the edge, and it's managed in the cloud. But then on a lower cost basis, you could take your camera feed, a standard CCTV camera feed, if you're doing maybe health and safety on a larger site with areas that vehicles don't go. The total cost of ownership of that would be less, because again, you're buying standard off-the-shelf cameras, and then you're going to get a processing element in the cloud which can scale to meet your needs. So that type of system, it's difficult to price that type of system, but again, if you already own the IoT and the cloud-based system, adding cameras can be bought very, very low cost, but even for good outdoor ruggedized cameras, they can be expensive enough. You're still maybe talking £500 for a camera, plus the cloud processing. I hope I haven't gone into too much detail, but as a rough guideline, those are the kind of prices.
And finally, just on the car one where it was picking up the vibrations, was that a camera or was that sensors, IoT sensors?
No, that was just a single camera recording a video. So it was recording in 5K, and essentially the AI algorithm can look at the differences between the images. So we can capture images. I think that was captured at, was it 60 frames a second? So 60 times a second, it's looking at everything. Whereas if you have vibration sensors, you might have to mount 10, 20 vibration sensors to get half the data that this image could, or that these images could produce. If we went down to lower resolutions, you could get hundreds of frames a second with a standard camera or a relatively low cost camera. So, but then the AI is layered onto that through not just the differences in the image, but in where things are moving relative to each other or vibrating relative to each other. So AI can calculate which direction things are vibrating, and then you could probably go into nodal vibration and all sorts of other things, you know, as you develop it.
Okay, thank you very much.
Oh, I see a question there. News story about cameras made in China and security concerns. Again, if you're an IoT developer and you've got your own cloud solution, it's likely that those cameras or cameras that you're using are going to be transmitting directly to yourself. Maybe there's a back door into them, but I would say it should be relatively easy to determine. I'll take that with a pinch of salt because it's probably not the case completely. But I would say there's been no proactive steps. I know the government has spoke out about it a few times, but I think security is everyone's responsibility. So it's just a matter of properly vetoing or vetting your technology.
And I think as well, and this maybe I'm oversimplifying it. Sorry, I was reading that out, but it was on mute. Whenever you get any device, and this really, you know, it'll come with a password. You know, here's your password. Change that password as soon as you do it, because I think what's that, Shodan.io? You can go into it's a website. It's completely legit. It's not, but you can go into it and it can show you. It's one of the first things that like Vertical Structure or whoever, a pen tester, will go in, and if you're saying, can you check all our stuff, they'll go into Shodan, and you know, it's amazing how many cameras. It just has all the open camera feeds into factories, into homes, into hospitals that people haven't secured, and it just has them up so people can see. Oh my god, see our
I think as a general rule, I would be a little tentative towards Chinese manufactured cameras. But again, if you're developing the IoT system, you may be able to mitigate against that.
Yeah, I'm just getting the link. Shodan.io. I'm not really sure how to search on it, but what we're seeing. Sorry.
So the laws on anonymizing data, just saw another question pop up there. Yeah. So it just comes under the General Data Protection Act, and essentially there may be other things there as well. So don't quote me completely on that, because maybe there's something different in terms of shops, but I expect it's the GDPR. So you could say, as I said, if you don't have to identify a person, but you could identify that this person, the characteristics of a person. So you don't know who it is specifically, but you could identify, say there's 100 customers, different customers come into your shop. You could assign each customer a number and say, this is customer number 1. They come in every Monday, they buy milk and eggs, and they don't shop anymore. You know, so that you've anonymized that data. You don't know who that customer is, but yet you've gained a huge amount of additional information. And is that completely anonymizing it? You could probably argue it is, but if you had other data and you aggregated that data, potentially you could identify that person with other information. So it is very difficult to truly anonymize information like that. But again, you probably would be okay with that approach, I expect, but don't quote me on that.
Any more questions for Sean? We've also, on one of our other webinars, FP McCall spoke about using AI to check concrete pipes, and it was a KTN project. So just taking the photograph of the pipe for quality control, so that and it's had a huge impact on their efficiency and pipes not being released that shouldn't be sold, whatever, because they were just able to say it. And it was, I think the problem was somebody could walk along and quickly go, that one's fine, that one's fine, but this person had 40 years or 30 years experience of doing this, and somebody coming in now would be like, oh, I don't know, I think it's okay, whereas this was able to show really quickly that what pipes needed to be taken out of the
Yeah,
supply chain.
absolutely. There's so many applications. Do I have time to answer that last question there, learning resources, or are we out of time now?
Yes, yeah.
So learning resources for startups or developers, or startup developers. So one thing I use, which I definitely recommend, I use Mathematica. The license is a few grand, but it's actually a really good high-level resource for playing around with neural nets and algorithms. Other things like this, there's good online courses. There's a lot of online courses if you search around. There's a website called brilliant.org, is it? And they've some good resources for learning AI and neural nets from a very, very basic level. But there's a lot of stuff there, and if you want to drop me a line, I could maybe point you to some places to start. But those would be good places to start, I think.
Brilliant, thank you. Okay, any more questions for Sean?
There's one more there. Sorry, I'm not pushing too long in terms of time. Can AI beat the beer game of supply chain management? I mean, in terms of correct assumptions of supply chain demands and forecast. Ooh, yeah, that's a big one. Yeah. So that definitely is more difficult because of the way the supply chain works. I would guess there's some mitigations AI could do for that, but it's definitely a difficult one to do because there's a lot of, the supply chain is nearly like the stock market. It can go up and down and it can be very unpredictable, but there are some algorithms that'll give you a general idea, but not necessarily protect you 100%. That's maybe the best way I could phrase it, but I think it could help. And probably does.
Brilliant, thank you, Sean. Thank you very much for that. That was really interesting. So I am going to if you can make me host again, please, Sean.
Oh, sure.
I will let everyone go for a cup of tea or coffee, and we'll meet back at about 11:10. I'll let Alan know that we've pushed him back 10 minutes, but that was brilliant. Thank you very much, and thank you for your questions,
thank
everybody.
You.
So, I'm going to recording, and then I'm going to make you host. Okay, Alan?
Sure. Yeah. Thanks, Clay.
Host. There we go. Okay, so but we're back to recording, everyone, and just saying, I think most people are back. So a big welcome to Alan. Alan, I know that we had Brian on earlier from the IoT Belfast group, and Sean is also involved in IoT Belfast, and I know Alan, that's how we met. I used to run IoT Belfast and we sort of ran in parallel, but so Alan, it's great to have Alan along today. So do you want to crack on, Alan? I'll put myself on mute.
Sure, yeah. You can see my screen okay, yes?
Yeah, perfect.
Okay, yeah, thank you. Hi, everybody. My name is Alan McCall. I'm the CTO at Sensoteq. Today, really, I'm going to talk to you about how IoT can be used in the world of predictive maintenance and really be useful in the industrial world to save money. First, I'm going to give a little bit of an introduction into the company and who we are, and what we do. I'm going to touch then on our product offerings, and then I'm going to give a little case study that try to wrap that all together to show how we do bring value to our customers through IoT. So first off, who are we? We're a company here based in Belfast, headquartered in Northern Ireland. We were founded in 2016 by myself and Adair Bedard. Adair is our CEO. We have been friends and colleagues for over 23 years. And between us, I think we have about 25 years each, over 50 years of experience in electronics and software, predominantly in the sort of wireless and sensing space. So we've taken that experience and brought it to the industrial world. And we have developed a remote wireless machine health monitoring system, and really leveraging IoT to the fullest. And really what our purpose is with this system is really to prevent failure and reduce energy wastage in the industrial world. And we do that by wirelessly connecting machines to the internet. So today we have quite a global presence, even though we're a little small company in Northern Ireland, but we are now selling our product in over 30 different countries around 5 different regions of the world here. And really have like a Fortune 500 companies, household names that you would know across the automotive, pharmaceutical, and then oil and gas sectors. And we sort of have a product that touches nearly every industry, because every industry has the same problem of downtime to try to take care of. And something that we're really rather proud of is that we make everything here in Northern Ireland, keeping the circular economy going well. So everything from our metal pieces, the plastic parts, the electronics, even our packaging, everything we do here is made in Northern Ireland and then shipped from here all around the world. So why do we have this system, and what do you have it for? Well, it's really because of the cost of downtime. The cost of downtime is getting more and more expensive. Caterpillar had a report saying that particularly unplanned downtime costs 5 times the amount of planned downtime. So downtime costs as it is, but it's getting more and more worse in the market. And this new report here from Sensoteq last year has really shown the dramatic increase across all different sectors, how downtime is impacting these industries. And that's come about in the last couple of years because of all the world events that's been going on, because of the pandemic, and obviously the war in Ukraine, the energy crisis, and the supply chain issues. All of these bundled together is just making it really, really difficult for companies to manage their operating costs. And that even tied on top of getting this skilled labor to help to rectify these issues causes some trouble. So how do you reduce downtime? Really, there's through maintenance of your machines is really a good way of keeping control of your downtime. There are many different types of maintenance that are used today. Some of the more old-fashioned and traditional ways was called reactive maintenance or breakdown maintenance, where you literally just go until it failed, which means you didn't have to store parts for inventory and you didn't have lots of costs to go out into the sites to constantly monitor them. You just waited till it failed. But that's not really relevant here today because of the cost of downtime. They don't want that to happen. Preventative maintenance is a very well-known and used adopted practice, where you do it on a tiny basis. So once a year, you would go and just automatically change the bearings out or continually lubricate the machine. But even doing preventive maintenance can have its own problems, because going to touch a machine, strip it down and rebuild it, it puts it into an infinite mortality state, where actually what can happen is, if it's not balanced or aligned and lubricated before it's recommissioned again, can cause problems in itself. So that's always a problem. And predictive maintenance, it may sound like a new term, but actually predictive maintenance is also been around for a very, very long time. The Navy years ago used to use stethoscopes to listen to the pumps inside the submarines. They also used a screwdriver, where they set the screwdriver on the asset and set it against their jaw on the bone and feel the vibrations. And of course, then even just touching the machine, feeling the temperature. So and they would use that knowledge on doing these methods and trying to predict what was going on with the machine. But where it gets interesting now is that obviously IoT has really brought that predictive maintenance element forward leaps and bounds, where we can continually monitor assets and giving valuable insights to those assets to the experts, who can then understand and be able to predict when the machine's going to fail, and even have like almost a remaining useful life of how many days, weeks, or months they have before that machine would fall over. So then they can go and schedule their downtime accordingly. So what product offering do we have? Well, we really, as I said, have had a remote wireless machine health monitoring system with advanced AI. We like to coin the term AI is not necessarily as artificial intelligence, but automated intelligence. Whilst our platform has lots of complex algorithms and analysis going on in the background. It's really, we deliver this intelligence in an automated fashion to our customers. And we really have a full end-to-end hardware and then software as a service solution where our customers would then deploy hardware within their facility, and then they would have a subscription to our software where they can log on and view all the data and subscribe to those alarms. I'm going to a little bit more detail in the next couple of slides right now in our system. So here's the sort of different solutions that we have on offer, a few different names. Sensoteq Kappa. It's used primarily in a plant maintenance environment, so your factories that would be automotive, pharmaceutical, food and beverage, packaging, things like that. Sensoteq Tau is used more for the mining industry, so it would be attaching to large machines like your screens and crushers, centrifuges, and conveyor belt drives. Then we have Sensoteq Chi, which is like a little small, compact, tiny sensor that's Bluetooth enabled. And this is really used as a service tool where an engineer will carry a set of 2 or 4 sensors on a mobile device, and they can stick the sensors on the machine to make an instantaneous reading and make some diagnosis there and then. That also, the data from that tablet mobile device can then be sent up to our Sensoteq Analytics, which is our cloud-based platform. So Analytics is our sort of other product, which is the central hub for all of it. So Kappa, Tau, and Chi data can all be brought up into Analytics and can be managed and viewed accordingly. So what are the type of failures which our solution can monitor and detect? Well, we can pretty much put the sensors on anything that's rotating. So it could be motors, pumps, compressors, fans, cranes, robots, centrifuges, gearboxes. There's really endless amounts of applications that could be driving any type of process. And with the signals and things that we're monitoring and looking at, we can be detecting things like imbalance, misalignment, pump cavitation, structural distance, electrical faults, and then mechanical distance. And then, of course, the big one, which most of the machines do fail on, is the bearings. So monitoring the lubrication of the bearing and the bearing failure. So how does all this work? Well, essentially we have lots of those different types of sensors there from Sensoteq Kappa or Tau. They either magnetically mount to the asset, or they're bolted or threaded into the machine. We monitor vibration and temperature. And we also monitor electromagnetic flux, which allows us to help to detect the speed of an induction motor that's driving the application, which is very key. Knowing the exact speed of the machine allows more detailed analysis further on down the signal chain. Our sensors communicate from sensors to a gateway, and we do that using a proprietary RF technology. It's not Bluetooth and Wi-Fi, and we've adopted something that stays away from that frequency range for a few different reasons. The customers which we've been talking to already have Wi-Fi networks saturated throughout their facility, and they don't want to bring thousands of sensors that are already talking the same sort of language within their factory. So we use a frequency much lower than that, which allows us actually to travel much further within the industrial world on the same amount of energy as a Bluetooth and Wi-Fi. And also that signal isn't as perturbed by the metals and walls and structures which you get in a factory environment. All that data is aggregated by the gateway, is then sent up to the cloud securely, and we can do that by either Wi-Fi, Ethernet, or cellular, whatever the customer chooses, or whatever infrastructure they allow us to use. Once all that data comes up to the cloud, we're further processing that, we're calculating, we're creating brand new variables and more parameters for analysis and storing that in a database. And then we have our web-based analytics software, which is that visual piece where it brings it all together, where we then process that data and we can send emails and text messages, alarms to the customer whenever we detect any issues. A little bit more about analytics. So analytics is a web-based software. It's a very scalable platform where we're leveraging AWS cloud technologies. so that as we add more and more sites and more machines and more users onto the platform, it's all automatically scaled without having to rebuild architecture every single time. It's mobile friendly, so all you need to do to see your data anywhere in the world is literally have a browser. That can be on a mobile device or a laptop. And the software gives you the data presented in many, many different ways, many different forms, depending on the type of user you are. So if you're a large corporation, you have many, many sites around the world, and you're responsible for that, you may just want the view on the left, which is the world view, and checking the status of my sites. Obviously, traffic colored yellow, green, and red for the health status. So you can have a view of all your sites around the world and see how they're performing. A site manager, plant manager, would predominantly want to use maybe the site view, who gets a holistic view of the site, and again looking at the production line to see which assets are performing or not performing, or it gives them the information to decide, do we start another production run? Do we start a new batch of material? And then they can also instruct their engineering team to go and any actions accordingly before they do start any new production campaign. And then you have your condition monitoring engineers at the detail, so they can look down at the machine health view and then drill down even further right down into the data, the raw data from the sensors that come and make their diagnosis from that. So next I'm really going to talk to you a little bit about a case study that will hopefully show this in a bit more detail. And this one's really about a gearbox defect that was in the food and beverage industry. So the background to this problem is that this customer had this large vibrating screen which filters the food coming along it. And they had there's two large exciters, gearbox exciters on the top of it that's making the vibrating motion. And they knew that they had a bit of a problem with one of them, but they just weren't sure how bad the problem was. And they didn't want to bring the machine down because they were going through a harvest or a period of time and production campaign where they could not bring this machine down. It would have too much of an impact on them. So they wanted to use our Sensoteq Kappa X and installed the sensors onto this and again with our gateway. And they wanted to be able to record the health of this machine, to be able to understand, could we keep pushing this machine a wee bit longer to allow us to get to the end of the production campaign, and then bring it down during a proper planned maintenance window. So typically these machines would usually run at about 840 RPM at 200 millimeters per second velocity, which is quite a large vibration in itself. So here is a couple of views of some of the raw data that's coming from sensors. Our sensors are transmitting data out every single minute. So every single minute you will get a velocity, an acceleration value, a temperature value across the three different axes of that. And then that minute by minute data gives you a very, very quick trending parameter, particularly some of these key ones here that allow you to give you a quick indication of alarm if something is changing and changing dramatically or not. So the picture at the bottom right, maybe not as clear, but this is the velocity. So as much as these machines are supposed to run at 200, already this machine is sitting at the start of the campaign at 300 millimeters per second. So they did know there was a problem with this machine. But throughout the campaign of the 4-month period there, the value stayed pretty steady with the velocity. But however, the peak or the graph on the top left, which is the acceleration peak to peak value, it did dramatically change, and it did trigger an alarm level, to which then it alerted them to make an action. So when they drilled into the platform, they looked at the detailed vibration spectrum. So the bottom graph, which is called the time waveform, there's basically 16,000 measuring points inside that piece of information. And that piece of information within our platform, you can do lots and lots of further diagnosis with this. And vibration analysts who do this know this stuff really well. And we turn that time waveform into the above graph, which is called a spectrum or a fast Fourier transform, and that can give them indication of the frequencies and amplitudes that are of interest to them. to be able to diagnose. Because essentially, that top graph is like it is like an ECG for a heart, where a doctor can look at an ECG and detect any atrial defibrillations or any cardiac problems. Vibration analysts can look at these known frequencies and amplitudes and discern what type of failure we're having. And that, a lot of those failures are well documented, and there are over 40, 50 years of research and analysis done on this. And what we have done is we have taken a lot of that expertise and those analysis and embedded it into algorithms so that we can look at this. And whilst an expert would look at that and say, yes, this is very indicative of an inner race bearing fault, we can put that into algorithms and our machine learning programs to be able to automate it, to bring that automated intelligence to life. I'm sorry, what I was meant to say is that these large peaks that are happening typically around that running speed. So every time there's something rotating, something's smacking and something's hitting very hard, and it's almost hitting plus or minus 40 G, which is an 80 G peak to peak, which is a gigantic amount of energy. And using the time or waterfall time graphs, you can see from the top red one to the very bottom blue is that changing over time. You can see that degradation. So using our data of the trending and these features here, and the alarm, which our program sent, our program was able to indicate that there was an inner race bearing fault. So not only can you tell what there's a failure, you can tell actually what part of the machine is failing. In particular, bearings have very unique dimensions, and every bearing has a different dimension, and they will have very, very specific frequencies and amplitudes. Basically, a signature will come out of a bearing, and you can detect which part of the bearing is at fault. And whether the customer they managed obviously to use our system to get to the end of the production campaign, and then they strip down the machine, and then they can look at the bearing here, and you can see the defect within inside that. And if they had left that any longer without any monitoring, this would have caused secondary and tertiary damage and essentially just destroyed the gearbox, which would cost even more. So essentially using our system, what they were able to do was to push that machine as far through to get to the end of their production campaign without having to bring it down. And they had estimated savings of about $60,000. So with a little bit of investment of a couple of $1,000s on a machine, they've returned their investment very, very easily and very quickly. So really, what are the core benefits really from our system as well? It is truly wireless, so that means that you can attach it and retrofit it very easily to any existing equipment. And it really allows them, once you've installed that equipment, it really helps with the safety aspect. You don't have to send manpower down to the site continually to make measurements against some maybe dangerous machines or machines that may even be failing, which could cause anybody some harm. Our customers do experience a very rapid ROI on our solutions. Typically, it is less than 2 months, which is pretty good. Our system does send that data out every single minute, so you can get real quick actions and trends of what's happening and allow you to get calls to action very, very fast. Our sensors are very robust. They've been designed to be the highest IP rating. We've had them ATEX approved, which means that they can be brought into explosive or flammable environments, such as oil and gas and mining and distilleries and whiskey factories and the like, even pharmaceutical facilities require products to be certified to that level. So it really gives us that we can cover quite a large variety of the market. And then also, I didn't explain it earlier, but essentially our cloud platform has an open API. That allows our customers to be able to extract and read data from our platform and bring it into theirs. So it allows us to integrate into already some of their condition monitoring systems that they have, and basically use our alarms to trigger work orders or actions within their own existing IT systems. And that means it's not necessary. Yes, we may be a standalone, but we could integrate well into their systems, allowing a full end-to-end maintenance solution. That's pretty much it for me. Thank you very much for listening, and I'm happy to take any questions.
That was great, Alan. Thank you. Has anyone any questions there for Alan? I was thinking, you know, when you're going about talking about the benefits, and it was something that has come up in the cobotics and robotics talks that we've had. If you're a company that's starting to use systems like these, it's more attractive to your staff as well, because they're upskilling, they're learning new systems. You know, they're not just working machines, but they're getting that extra, you know, the visibility of stuff, seeing how stuff works. You know, it makes it maybe more attractive to another job that isn't using such technologies.
Yeah, I mean, certainly what we've seen, where we're coming from as in the market, is that we want to be the reliability team. We want to be part of a reliability team's program. We don't want to replace it. We're certainly not coming in and saying we're going to take over your jobs and we don't need you anymore. In fact, it's the actual opposite. We want to be there so that we can give them that holistic view and allow them to focus their expertise in areas so that they can go and fix the machines that need to be fixed and don't touch the ones that don't need to be. But you're right, they're coming in there and they're learning new skills. They're learning how to use these technical platforms to their advantage rather than being maybe apprehensive about them. And certainly we're coming very close with our customers and adopt things with them. In fact, we listen to our customers very closely because they're the ones who tell us, could you do a graph like this? Could you do this? Could you do that? And then we go and we help develop the platform in line with what they're requiring, which keeps them on side.
Yeah, brilliant. Has anyone any questions there? I'm just scrolling down.
Yeah.
Hey Alan, thanks for that. That was really interesting. The question I had, whenever you get all your sensors in Northern Ireland, which is interesting. And the software also looks great. Did you work with outsourcers a lot, or did you take a lot of that in-house, or what did you end up doing?
Everything you can see there, from the electronics, the mechanical design, to the gateway design, the software, the cloud architecture, and full front end, everything, even all of our mobile apps, everything is done in-house.
Very good. That's really good. Yeah.
And all from Northern Ireland so far. Don't get me wrong, it's been very challenging. Software market is a very, very difficult market.
Tough, isn't it? Yeah.
we still struggle with that, and we're happy to take anybody who knows how to relate some good software. So.
Yeah, well, the platform looks great. I'm particularly impressed that you managed to get hardware from here as well. And, we've went down that kind of rabbit hole before as well. But like, you've got the people in-house. It's just pretty impressive. All right, well, that's mine. Thank you very much.
That's the question.
About energy and wastage with the net zero stuff, is that sort of a big driver as well for companies to engage with these technologies?
It is. More and more research coming out now that shows that actually per running machines actually consume up to 10% more energy. So it's not only, is the machine potentially failing and it could impact your production line, it's actually consuming more energy. So and we all know where the energy prices are going. So using our technology not only to help them to repair their machines faster, to reduce energy wastage, actually some of our sensors can actually detect the relative change in energy consumption. So our latest sensor, which we brought to market, which has that electromagnetic flux, it can actually read that signal and can detect changes in energy consumption. So it's something we're bringing to our platform down our roadmap, is actually try to help our customers visualize that in a way of seeing how much money they're wasting on energy with their facility, or certainly not necessarily the actual value, but a relative change. If it's getting worse, you're spending more on your energy, then you need to go to address that. So certainly we are, it can be used to help leverage them initiatives for sure.
Brilliant. Okay. Any other questions for Alan? You can shout out there. I'm just scrolling through. I don't think so. Any more questions? No. Alan, if it's okay.
Happy enough to follow up with me by email. No problem with that. Reach out. We can answer any questions.
Super. And I'll share your slides. That's great. Look, thank you very much for that. It's just after. Oh, one new message. Hang on.
Here.
I'll pick that up later with you, Raj. I don't know if anyone will be able to help you, but we can certainly see. But it's not really the purpose of this is just to tell people about IoT and stuff. But I'm not sure really is what I'm saying. But anyway, so Alan, thank you very much. I'm just going to give everyone a quick overview of the digital search program, and I know some of you are already on it. Alan, if you want to make me host again as well, please.
Let's see. That is just to Zoom as Teams.
I know. So if you go over to my square and then make host.
Yeah. Is that right now?
Perfect. Thank you.